If the coastal defenses guarding the Netherlands were to vanish today, the North Sea would reclaim the economic and cultural center of the nation. To see the scale of this threat, we look at this comparison. While 26% of the country sits strictly below average sea level, nearly 60% of the land is vulnerable to flooding from the sea or major rivers. The extremes of this geography are severe. The lowest point in the country sits 22 feet below the 0-meter mark, and Schiphol, one of the world's busiest aviation hubs, operates up to 4 meters beneath the waves. This landscape is a human product. Without a continuous system of drainage, the post-glacial region would have remained a marshy estuary governed by shifting tidal creeks and silt. When generations of citizens drained the original swamps, they inadvertently triggered a process of peat oxidation. As the organic material was exposed to air, the soil elevation dropped, causing the ground to sink even further below the surrounding water. The existence of the Netherlands is an active, ongoing defiance of its own geography. Modern water management was born from the violent memory of natural breaches. In 1421, a powerful storm surge pushed up the rivers and annihilated the poorly maintained earthen dikes of an agricultural region. This disaster, known as the St. Elizabeth's Flood, swallowed 72 villages and permanently converted a fertile polder into an inland sea. 5 centuries later, the vulnerability of the Low Countries was exposed again. In the winter of 1953, a severe North Sea storm coincided with a high spring tide. The 1953 flood breached the nation's defenses in hundreds of locations, killing over 1,800 people and drowning approximately 200,000 livestock. Under the leadership of Queen Juliana and Prime Minister Willem Drees, the government launched a national rescue operation and resolved to engineer a system that could withstand the ocean's worst-case scenarios. The trauma of the 1953 disaster served as the catalyst for an immediate acceleration in Dutch civil engineering. Before the Dutch could build physical barriers, they had to engineer a societal framework that could fund and maintain them. This birthed the water boards, some of the oldest democratic institutions in the world. They were founded on a simple reality. If one farmer failed to maintain a section of the dike, the entire community would drown. This forced a system of consensus, known as the polder model. Stakeholders were taxed based on their financial interest in keeping the land dry, requiring constant negotiation between residents, farmers, and industry. This collective funding powered the mechanical fight against the sinking land. In the centuries before electricity, gangs of windmills were built to lift water step by step out of the deep polders. By the industrial era, this effort was scaled by the DF Woda pumping station. Its steam engines drive pumps capable of moving 4,000 cubic meters of water per minute, a capacity that remains critical during extreme rainfall today. The machinery keeping the country dry is a direct reflection of the democratic consensus that has maintained it for 700 years. The most ambitious part of this defense is the Delta Works, a project designed to shorten the entire Dutch coastline by closing off major tidal inlets. This risk assessment matrix illustrates the Delta norm. To justify the cost of the barriers, engineers valued a human life at €2.2 million and established that coastal defenses must withstand a storm expected only once every 10,000 years. This engineering strategy peaked with the Maeslantkering, a movable storm surge barrier protecting the heart of Rotterdam. The gates are anchored to the shore by white steel truss arms. These arms distribute hydraulic pressure through massive ball-and-socket joints, each weighing 680 tons. The operation is entirely automated. When supercomputers predict a surge exceeding 3 meters above normal sea level, the system initiates closure without any human intervention. To create a seal, the barrier floods its own hollow compartments with river water, causing the steel walls to sink, forming a rigid, impenetrable dam. These gates represent the peak of a strategy defined by absolute, unyielding resistance against the North Sea. But climate change has revealed the limits of rigid walls. Increasing rainfall and glacial melt are driving winter river levels higher, proving that concrete dikes cannot be raised indefinitely. This realization led to the Room for the River program. Instead of building higher barriers, planners are now widening channels and creating bypasses that allow the river to expand safely. In Nijmegen, engineers relieved a bottleneck in the Wal River by moving the main dike 350 meters inland. They excavated an ancillary channel that lowered high water levels while creating an urban river park designed to flood occasionally. This strategy has evolved into a wider practice of utilizing natural processes to solve engineering problems. This is visible in the Marker Wadden project. Instead of dredging lake bottom silt and disposing of it, engineers utilized the sediment to construct a massive artificial archipelago that restored the local ecosystem and stabilized the bird population. Long-term resilience requires planners to integrate with the natural dynamics of the landscape rather than attempting to override them. In dense urban environments, planners responded to rising sea levels by decoupling homes from solid ground. In the Eiburg district of Amsterdam, residential blocks are built on submerged concrete tubs. These foundations ensure the entire neighborhood remains buoyant and stable as local water levels fluctuate. To make this viable, engineers developed flexible utility connections for the jetties. These pipelines are actively heated in the winter to prevent freezing and cooled in the summer to maintain water safety for the residents. This floating model achieves the same housing density as Amsterdam's historic center while neutralizing the financial and physical risks of a rising sea. The survival of the Netherlands proves that a society can thrive by integrating its civilization with the shifting dynamics of the water surrounding it.